how to build low-cost pool heaters, and some performance results. I have a largish pool, about 50,000 litres, and enjoyed DIY, so making a pool heater seemed a good project. Later I built 3 others. Each was slightly different design, using new and recycled materials. A pool heater has to be angled to catch the sun's heat. In spring-summer, the sun will be much higher in the sky. If you want to use the pool mainly in these periods, the heater angle should be about the same as your latitude. For all-year pool use, you need a higher angle and a huge number of pool heaters. Not really practical. A higher heater angle will be less efficient in the warmer months come along. In the northern hemisphere, the heaters should point south. In the southern hemisphere, it should point north. My heaters consist of a timber box with a rear cover, a layer of polystyrene insulation, a metal plate painted matte black, a coil of polypipe supported above the rear plate on something metallic to give heat transfer. The box should be topped with a clear UV-resistant plastic or perhaps glass. My boxes were mainly made of 90 by 35 timber studs. The box rear cover approximately 6mm plywood. The polystyrene was 25 to 30mm thick. The heat plate was either steel or aluminium, approximately 1mm thick. The matte black paint was just basic spray enamel. The tube support straps were either galvanized steel bracing straps with lots of handy holes or something similar. The polypipe I used was 13mm ID, 15mm OD. This seemed ideal as it was black, lightweight, cheap and locally available. It was also easy to use, flexible, had a reasonable bending radius, and the water inside could be easily heated with its large surface area for capacity. Fittings were cheap and available. I was given some 3 or 4mm plastic sheets suitable for heater covers and made up boxes to match their size. I started with a 50-meter, 164 feet roll of the pipe and wanted to make 2 adjacent pipe runs for cross-heating. It was a bit tricky doing this with this long roll. 2 25-meter rolls would have been easier. I attached a poly pipe to the aluminium box sections using a generous number of cable ties. I took care that the pipe was fully supported and closely positioned. I left a suitable length outside the heater for pump connection. The pipe runs started at the heater outside and worked inwards because the central area of the heater should be warmer than the perimeter. The holes exited the heater box at the opposite end to the entry, again leaving enough length to bring the discharge pipes part way into the pool. Don't try to install too much tube. You might end up with kinks. They are bad news. Do not exceed the bending radius. This damage was later cut out. Ending up with an empty area at the heater center is okay, as it will absorb heat which will be conducted across the heat plate, thereby heating the backs of the tubes. Once the tube is all in place, add a temperature gauge attached on the underside of the tube array near the outlet. Attach the cover with stainless steel screws in case you need to remove it. Finish off with aluminium trim and more stainless steel screws. The most attractive solution would be to mount the heater out of the way somewhere in a location that gets sun all day. For test purposes, the pool heater will be mounted at the pool size. This is very convenient and efficient, but not really very pretty. I can live with that during the testing period. Mounting the heater remotely will require more pumping power, longer feed and return lines, and perhaps some of those lines might require insulation. The pump controller sensor was connected to the underside of the heater pipes near the center of the pipe array. I also fitted temperature indicators for pool surface layer, pool bottom and heater body. I had a properly earthed power socket fitted for the controller output. I fitted the heater cover and trim and positioned it by the pool. I connected the heater suction pipes to the submersible pump. For an initial value, I set the temperature controller starting the pump at 40 C and stopping it at 35 C. These values should ensure that it only pumps when worthwhile. After pumping the hot water, some cool will be pumped as the heater pipe is quickly cooled by the pool bottom water, but it takes a few seconds for the temperature drop to reach the controller sensor. The pump will typically run for a number of seconds, followed by a period of minutes while the pipes reheat to the pumping temperature. On initial tests in spring, the pump ran for approximately 40 seconds, time between pumps approximately 16 minutes. The heater's internal size was 790mm by 1850mm, giving 1.46 meters squared or 15.7 square feet. Heating a 50,000 litre pool is a big ask for a smallish DIY solar heater. I had a spare sheet of plastic, so decided to use it as the basis of a second heater. The second heater would be a simpler design. The new heater would require a support frame for the poly tubes. I wanted to keep this as light and low cost as possible, so made up 2.5mm 1-inch straps and attached them to the other small angle brackets to the timber frame approximately 2.5 centimeters above the steel backing sheet. They were made up just a bit short end to end so they could be pulled tight. 2 straps were fitted end to end, 8 straps were fitted side to side, and a central block to support the center. The second heater would be mounted side on to the pool to take up less pool area space. Holes were drilled through the frame at either end for the poly pipe entry and exit. Poly pipe was installed as before, avoiding any kinks. Total pipe length 100 meters. After establishing that this system works, It was time to come up with something more acceptable, long-term and easier to live with. One of the first changes was the removal of the submersible pump and its replacement with a pump mounted on the pool side. In the new location, the heaters get the sun for most of the day. The pump for both heaters is controlled from either of the heater's temperature controller. One controller is set to start the pump at 42 and the other at 38, as it is consistently cooler. I have each of them turn off 0.1 C lower than the start temperature, as the indication is slow to drop. At my install, the pool heaters and pump have negligible running costs, as the pump will only run when the panels are hot and when the sun is shining, creating free power from my solar PV panels. On sunny days, if for some reason the pump is out of service for a lengthy period, the heater should be fitted with sun-reflected covers to stop the pipes overheating. The maximum temperature polypipe should be subjected to is 82 degrees Celsius, 180 Fahrenheit. Check out the next picture for what happens if this is ignored or somebody turns off the pump. It is now Australia's Queensland winter. The heater covers were removed 12 July 2021. The pool temperature was 16.3 C. Today is 23rd August 2021. The pool temperature is now 22 degrees C. The pool has a tightly fitted cover and in addition a second cover that excludes all light from entering the pool. The pool filter runs approximately 15 minutes per day to circulate the water. This video was produced as a possible assistance to someone who may be considering a DIY solar pool heater. It may help you avoid some of the problems I encountered. It is a low cost rather than a Rolls-Royce solution. I know it could be done better. Forgive me any typos. I'm a retired engineer, not a secretary. Electrical work should only be carried out by suitably qualified tradesmen. If you like DIY and international travel videos, please like and subscribe. This is just my hobby. There are no adverts or requests for funding. Bob Jackson.